Introduction to probability. Now, what is probability? So, since probability is best explained in examples, I'll give the example of a coin here. And this coin, let's say this is the heads, and then I'll make it 3D. The opposite side is the tails. Now the question is, what's the probability which is P, of the coin flipping tails? So what this is basically asking you is give it a value that explains the chances of getting tail. So I've probably guessed the value is like some say 50% and some say 0.5. It's the same value. And they're both correct. So now let's put this into a formula that we can use in other examples, since this example is pretty common sense. So out of the number of elements in our sample space, a sample space is all the possible elements or events we can have. So in our case of the coin, the sample space was only two things, which is the head or tail. So the number is 2, so the denominator is 2. I'll write this, I'll make this more clear. No, that's not it. So the number of elements in sample space. And in the numerator, it's the number of elements that satisfy the condition we asked for. In this case, the condition is getting tails. Number of elements that satisfy condition. So in the case of the coin, the number of elements in the sample space is sample space again is head and tail. Number of elements is 2, and the number of elements that satisfy that condition is 1. Okay, so for this question, they're giving us 12 balls. 3 red, 4 green, 3 blue, and 2 purple. They're asking us what is the probability of grabbing a blue triangle from the box. So first we follow the formula. They're asked its number of elements that meet the condition over number of elements in the sample space. I like to do the denominator first. So number of elements in the sample space. First we have to identify the sample space. So all these are in the sample space, so I'll just name them for clarification purposes. So purple 1, purple 2, blue 1, blue 2, blue 3, G1, G2, G3, that's G, G4, R1, R2, R3. So these add up to 12. So the probability is over 12. Then the number of elements that meet the condition is 0, since we don't have any blue triangles in the box. And 0 in the numerator is always equal to 0 unless this is equal to 0, then it would be an undefined number. So since this is 0, it is what we call an impossible event. So when the probability is 0, P is 0, event is impossible. Okay, second question. What is the probability of grabbing a green ball from the box? Again, following the formula, I'll do the denominator first. So number of elements in the sample space has 12 balls, so it's 12 number of elements that meet the condition. So how many elements meet our condition? Our condition is a green ball from the box. So how many green balls in the box are there? There's one, two, three, four. So it will be 4 out of 12, which is 1 over 3, or 0.33, whatever is in the answer choice. Usually they'll give you the simplified version, so you'll usually have to simplify it and get this answer. Okay, for our third question, what is the probability of grabbing a green ball or blue from the box? So when they say or, you would add the probability. So you'll get this probability first, and then get this probability first, then add them together. So the probability of a green ball is 4 over 12. We did this in the previous question. And then blue ball, the number of elements in the sample space, 12, already discussed. Then blue balls in the box, there are 3 blue balls, so it will be 3. So it's 7 out of 12. And that's the probability of a green or blue ball. So for our fourth question, it's asking what is the probability of grabbing a ball of any color from the box? So again, we'll use the formula P equal to, we'll start with the denominator, number of elements in the sample space. So it's 12 as we discussed in the previous question. Then number of elements that meet the condition. Now the condition is a ball of any color from the box. So how many from these satisfy this condition? All of them do. So it will be 12 over 12, which is probability of 1. So what does a probability of 1 mean? A probability of 1 means that this will 100% happen. It will happen 100% of the time. It will always happen. Nothing else can happen. So when you grab something from the box, it will always be a ball of any color. It cannot be anything else. There's nothing else to grab. So one more thing about the probability is it cannot be greater than 1. 1 is the max and 0 is the minimum. There you cannot have negative probability. Cannot be negative 4.34, 3.43. It cannot be 1.28. It cannot be greater than 1. It cannot be less than 0. 0 means it will never happen, and 1 means it will always happen. The closer it is to 1, the greater times it will happen. The less close it is to 1, the lower the chance it will happen. Mike's probability of scoring a goal is 0.35. What is the probability of him not scoring? So these two events are events that we call complementary events. Complementary events. So complementary events are events where there are only two options. In this case, it's either he scores or he does not score. And as in the previous question, we discussed that the complete probability of anything is 1. So since there are only two options, these two options will always add to 1. So the probability of him scoring plus the probability of him not scoring will equal to 1, will equal to the complete probability. If we had 3 probabilities, for example, and these are the only probabilities we have for that event, it will equal to 1. It will always equal to 1 as long as you mention every single probability. Now back to our question. So again, since these two events are complementary, Mike can either score or not. The total probability will equal to 1, and the probability of Mike not scoring a goal will be 1. Oh, I'll have to delete this. 1 minus the probability of scoring will equal to the probability of not scoring. And in the question is given that the probability of Mike scoring is 0.35. So the probability of him not scoring will be 0.65. Okay, when comparing data, you will be given an experiment and how many times it will be performed. I'll give an example. Let's say a pandemic spread and 400,000 people got infected. 400,000 people got infected. So, out of the 400,000 people that got infected, only 200 suffered symptoms. So, severe symptoms. Severe symptoms. So, the formula for data and anything similar to this is the number of times an event happened over the number of times the experiment was performed. So, in this example, every time a person gets infected, the experiment is performed. So the denominator will be 400,000. And the reason why this is the case, the reason why every time a person gets infected, an experiment is performed, is because when a person gets infected, he goes through the percentage of suffering through severe symptoms. So that's why. So back to the numerator, the number of times an event happened. The event in this case is the severe symptoms, so it is 200 over the 400,000. So it's 1 over 2,000. So it's 0.0005. Okay, so in the same question again, since the person who gets infected can either get severe symptoms or not get severe symptoms, these are complementary events. So since they're complementary events, when you add the probability of two complementary events, alright, this is complementary event number one, this is complementary event number two, they will always add up to 1. So for example, this is the probability of getting severe symptoms. So let's say this is complementary event number one, so it's 0.0005 plus complementary event number two, which is not getting severe symptoms. So I'll write this as P2 or PC2, I'll keep it the same, equal 1. So it will be 1 minus 0.0005 equal to PC2. So it will equal to 0.9995. Okay, so an extra thing that you will be responsible for on the day of the test is the standard deck of cards. So you'll have to know these information and you'll have to be very familiar with the deck of cards. You'll have to know that each symbol has 13 cards, each color has 26, the whole thing has 52, the names of each symbol, and etc. Okay, second to last idea of the last union. So when you asked about the probability of two things, you have to make sure that you're not adding duplicates. So for example, if they ask you about how many three cards there are, cards with the number three, which are these cards, I'll write them in a different one actually. This is the threes. This is not clear at all. Okay, so these are the threes. And then asked about the hearts. So I'll do it in a different color. Asked about the hearts. You have to add them while making sure you remove the duplicate here. So as you can see, both colors override at the 3 of hearts. So you'll have to remove one to remove the duplicate. So lucky for us, there's the formula that can do that. So it's probability of A being the probability of first event, then U being the sign of union, which means it's the addition of both without any duplicates. So that probability equals to the probability of A, which in this example is 3, quotation or parenthesis, plus the probability of B, which is the hearts in this case, minus the probability of A intersection B. So here we're adding both probabilities and then we're removing okay, so let's do an actual example using the deck of cards we have here. So let's say they ask, what is the probability? I'll write it down. So, what is the probability of the no, of that a card is an ace or a king? Okay. So here they're asking, what's the probability that a card is an ace or a king? So first we get the probability of one and the probability of other, and then we remove the intersection. So first, let's say A is the probability of ace. So we know there are 4 ace cards here. This is from our knowledge of cards. So it will be, the probability is 4, which is the number of ace cards, over 52, which is the number of cards in general, plus probability B, it's the king. There are 4 king cards. So it's 4 plus 52, which is again the number of cards in the deck. Then minus the intersection. But here, since it's an ace and the king, there are no intersections. So it's minus 0 over 52. So it will just be 8 over 52, and then you simplify. It becomes 2 over 13. Okay, so here we had no intersection, but let's say we did. Okay, let's make another question. So what is the probability that a card is? What should we make it? Let's say red card or an ace. Okay. So here again, we'll find the probability of red card and then ace and remove the intersection. So a probability that a card is red is half the deck. So it's 26. This is again from our knowledge of cards. 26 over 52 plus, and ace we already did here, it's 4 out of 52. Then minus the intersection. So red card and ace. So how many red card ace we have? We have 2 red card aces. So we subtract 2 out of 52. And then the answer will be 28 out of 52, which is 7 out of 30. Okay, so same idea again, but this time instead of a deck of cards, we have a table. What is the probability that a random individual selected will be a male or from the Air Force? So first we get the probability of the male and then probability of them, anyone being from the Air Force, and then we subtract it by the intersection. So first probability of a male, is 79 over 100. So 79 over 100, and plus Air Force. Air Force is 16. No, Air Force is 22 out of 106. 16 if it's only male. So it's 22 out of the 106. The reason it's out of 106 is because they ask if a random individual is selected at random, so we use the whole total. Then minus the intersection. So the intersection is a male from the Air Force. So there's 16, so we subtract 16. Then we can use a calculator. So 79 plus 22 minus 16 over 106. It will be 0.801, or in fraction it's 85 over 106. Okay, so our final idea is the idea of the probability of independent events. So the probability of flipping heads in a coin is 1 over 2, and the probability of landing, for example, 3 is 1 over 6. So since these two events are independent of each other, the probability of both of them occurring is the product of both of them. So this is a rule. I'll write it down. B is equal to A. A again is the first event and B is the second event. So probability of B and A and B both occurring is the probability of A times the probability of B. So in this case, A is the coin flipping heads on the coin, and B is landing 3 on the dice. So it's 1 over 2 times 1 over 6, so it's 1 over 12. So the probability of both of these events occurring is 1 over 12. And that's the lesson.
That'll be it for lesson 12.7, Introduction to Probability. If you have any questions whatsoever, want to ask anything at all, you can ask it in the comments or in the server. If you want more math tutorials, you can find them in the channel, or any other tutorials for any other subjects as well. And that'll be it. Enjoy them.